Hi everybody, I'm Angela and I'll be one of your Swarwood online guides.
Here's a great question that it's actually about uniform distributions as well. So again, one more about uniform. Right? Remember, really quickly again, the uniform really, it's pretty mellow. It's just basically length of what you want over total length. Okay? And we're going to do this question. So his question was this. You have a rectangle, and the perimeter of the rectangle is something like 20 centimeters. Okay? And its length over here is uniform from 1 to 7 centimeters. Okay, something like that. Okay, so let's go ahead and work this out. So the idea would be, oh, and obviously I forgot the question. So the question was, so what is the probability that if you look at the two sides, right, these two sides, the longer of the two sides is greater than, say, 6? Okay, so I believe greater than 6 centimeters. So the setup is uniform on 1 to 7 for this side. What is the probability that the longer of these two sides, right, is greater than 6 centimeters? Okay, so why don't we break it up into cases? I'm not going to be super formal about this, but let's break it up into cases and see. So for one, since this guy in here really ranges from 1 to 7, it's possible that this guy might just be bigger than 6, right? So what are the possibilities? He can go from 6 to 7, right? And that would make him bigger than 6 centimeters. Technically, we should check that he really would be the longer side. If this guy were 6 and this guy were 6, that's 12. The total perimeter is 20. So if you subtract 12 from there, you'd have 8. So these sides have to add up to 8. So it would be 4 and 4. Okay. So if this were the setup, it would be good. This really would be longer than this side, right? And when he's 6 and he's 4, we're good. Okay. So see, pretty mellow, right? So if this guy were 6, it would work out. Because, well, technically he's just bigger than 6, but it's all good. So, and if you were bigger than 6, like 6.1, 6.2, 6.9, 6.99, whatever, all the way up to 7, we would still be good, right? Because this longer side would be 6 or bigger. Okay, so if that's the case, what's a good range for us? So one possibility is, what do we want? We want something from 6 to 7. What is the length of what we want? 7 minus 6, well, you can see that there. It's a length of 1 unit, right? Okay. What's the total set of possibilities? Well, you can range lengthwise from 1 to 7, right? So 7 minus 1. So I guess that's one possibility out of 6. Okay, not too bad. Okay, but that's only part of it, right? That's assuming this is the longer side. Don't forget, the other possibility is the other side might be the longer side, right? Okay, so let's do that. So if the other side were the longer side, then for the longer side to be bigger than 6, so this guy would have to be 6 or bigger. See, a similar setup, then this would be 6 or bigger, which means that these guys are at minimum 6 and 6 is 12, 20 is all the way around, so again, we get 8, same sort of thing we had before. So that means, since these guys are equal, this would have to be 4 and 4, right? So what that means is when this is 4, these guys would be 6, so we're going to meet that qualification. So just bigger than 6, right? Okay, so what if I made this guy smaller? So what if you were like 3.9? Well, if these guys were smaller, right, just a 3.9, 3.9, then the only thing that's going to happen to these guys is they're going to get bigger. Do you guys agree? So you're guaranteed this is going to be 6 or bigger as long as this side is 4 or smaller, right? Okay. Again, in uniform distribution, it's not a discrete distribution, it's uniform, so one point doesn't matter. So anything dealing with bigger than 6 is the same as 6 or bigger. Okay? Remember, it's not a discrete distribution, it's uniform. So let's take a look at that. So in that setup that we just did, we need this side to be 4 or smaller. The smallest you can get is 1, right? So what do you want? You want 4 down to 1, so that's a possibility of 3. So 4 minus 1, length of what you want. Total range of possibilities, 7 minus 1. So again, we're going to get 3 over 6. Okay. So now, here are the setups. When this is the longer side, you would get what you want, right? So you're completely done doing it this way, where this side is the bigger side, makes you happy. Here is a completely different way of getting what you want, where this time, this is not the longer side, the other side is the longer side. But you still be happy, right? Because the longer side would be bigger than 6. Okay, so one way of getting what you want, a completely different way of getting what you want. When you have two different ways of being happy, then you add. So in this case, it would be 4 over 6, or 2/3. So again, for that last step, if you're in the middle of counting and computing things, you multiply. But if you have computed different ways of getting what you want, and you're completely happy, right? So this way we would be completely happy. We would win because this side's longer than 6. This way would be completely happy because we'd win because the other side would be longer than 6. Either way, he didn't require a specific side. He just said the longer of the two sides is bigger than 6, right? So one way, another way, put them together, 2/3. Okay. So everything is good. And if in that last little bit you're wondering like, why is it possible? Because he wanted bigger than 6, then I started counting at 6. It's okay because it's a continuous distribution. So basically being just bigger than 6, like 6.1, 6.001, stuff like that, you can pretty much think of it as 6 or bigger. Okay? The technical reason why is because when you look at a side, for example, and you wanted this side to be length what? Let's say 6 or above, right? This is the length of what you want. But what if you said I want it to be just bigger than 6? Well, every point bigger than 6 works. You just take that point 6 out. But taking 1 point out doesn't really change the length. So the length is still basically 1. Okay? No rule of thumb on continuous distributions, single points don't matter. But on discrete distributions, points do matter.
So see you all next time.